Hello and welcome to AgDealerTV. I'm your host again this week, Scott Garvey. Well, it's raining outside, so I'm here in my office. Last episode, you saw I spoke to AGCO's Josh Ekholm about the AutoDock feature that was introduced for the IDEAL Fendt combine. Well, during the conversation with him, I also had a chance to talk about how artificial intelligence is affecting not only the way machines work, but how we control them. Here's a look at our conversation. Well, let's talk a bit about artificial intelligence. Now, I assume that was played a big role in the development early on the IDEAL because of the features built into it. Excuse me.
Yeah, and I would maybe say it the reverse way. I mean, the farmer and the customer asks, and the features, the feedback that we got from them, the feedback we got from field test, from an electronics and software perspective, that's where it started. And then it was more that the artificial intelligence, like that's part of the how, right? And it didn't start from, hey, let's go out and advertise AI with this machine. It started off with, let's resolve these asks that the customers have, that our farmers have, to improve their day, to take the stress out of it, to make them more efficient, to improve the performance of the combine, reduce grain loss, all that kind of activity that they deal with, to basically make that easier. And so the artificial intelligence piece of it, it's kind of a step on this evolution, right, in technology, right, from the lever that's connected to the cable onto maybe the switch that's connected to the wire that's connected to a valve, right, something like that. That was still manual, and we've got lots of examples of things that we've started to automate that are simple, that have a simple system, maybe not even with a feedback from a sensor. That's how it started. And then as we have seen, what we really need for that system to learn is robust, reliable, well-placed sensors, right? So in order to actually judge the performance of the machine or whatever system we happen to be focusing on there, we've got to have that reliable sensor feedback in there. And we knew that at the beginning. If you want to talk about the foundational principles on IDEAL, like that's really where it's at. From IDEAL Harvest with the automation to even things that we've had forever, since the beginning, like unloader swing, where we added sensors to that system to improve what we could do. I mean, that's probably maybe one of the simplest and clearest examples of kind of that artificial intelligence, is just being able to swing the unloader out and the calibration capture everything that it needs to, so that we can see a consistent swing in or out, regardless of within range, within boundaries, right? Friction, if the tube is full of grain, the incline of the combine, all these other items that we have that we can measure, now are a part of that control system, now are a part of the intelligence for something as simple as swinging the unloader out. And that allows us to have a wider variety of components that we can select to install on the machine, maybe more generic, maybe a lower part price or something if a customer has an issue later on, that they're going to be able to see that benefit that we've added there. So without giving too many examples of it, yeah, that the artificial intelligence, I mean, what we really learned was we needed data, and we needed reliable data, which meant we needed really good, reliable sensing mechanisms in the machine. And that started the ball rolling, really, for where we've ended up here today with the IDEAL machine.
Any idea how many sensors are on an IDEAL?
Ooh, that would have been a good one. That's a good Jeopardy question. I'll have to do the addition to get up to that. But as an example, within our IDEAL Harvest, I mean, just inside the machine that's judging how that's going, it's at least, depending on the model and everything, it's at least 30 sensors right now that are just focused on individual pieces that are focused on that side of it in just that system.
How much has this affected how controls are in the combine? Like, we've seen IDEAL now come out with a really one-off in the ag industry, the fighter pilot kind of control with the joystick. Is AI driving that? Electric components be driving that? What's behind that? Do customers want that? I mean, Why get away from the
Yeah, good question. That's interesting. I mean, to go back to the beginning of that, we literally had customers at their kitchen table saying, "Get rid of the steering column." Right? That it was all about visibility for some of those customers back then. They wanted to see specifically in soybeans and maybe higher yielding soybeans, double crop soybeans, scenarios like that where feeding was a concern or an issue, and they wanted to keep an eye on it. And it was get it out of the way. So we heard that pretty consistently, pretty loud and clear, and that's probably one of the best examples of coming full circle and immediately seeing the customer happiness with it as soon as they get it on their own machine. Got two machines I can think of right off the top of my head that started harvesting in another land about 2 weeks ago, and it's absolutely their favorite feature on the machine. They are in love with it, and it is, it's another one of those features that certainly has its place, maybe where it's going to be seen as more value. When there is more manual steering, when there are smaller fields, waterways, terraces, scenarios like that are maybe odd shaped fields where the customer is really going to feel the benefit at the end of the day of not steering constantly to get around those. Yeah, I think we're seeing that come in now. As far as tying it in with the artificial intelligence and the electronics, there we were, it was kind of a collision of a lot of requirements with that particular feature. We had some really strong safety requirements, as you would have anytime that we're involving the electronics there with the direct steering, especially at the speeds that people want to travel on the roads, and in all the regions that we want to make it safe to travel on. And what we really did with that scenario was we put the boundaries, we put up the guardrails on where that system needed to function in terms of the dynamics of the combine, what's safe, what's reliable, and what also, maybe that's kind of on the conservative end, and then maybe on the more aggressive side, that customer can still have the control that they have with the steering wheel to make an aggressive change if they need to. So our goal in that was really to establish those guardrails to it. And we worked with some of the, I'll just say, the automotive leaders in safety in North America on that topic. And they tested it for us. And we set up those boundaries. We made some adjustments to what the curve looks like for steering. And then we also implemented a lot of logic relative to the safety and to the feedback of how the system was performing. So we had some really important requirements there to keep our operators as safe as possible, but also enable this feature that turns out to be really cool. And it is really fun to drive. The experience that you have with that machine, where you have that kind of control in one hand, is great. And to go back to the individual I'm thinking of at his kitchen table, with the voice of customer probably almost a decade ago, yeah, get the steering column out of the way, because that visibility is fantastic. You may not notice it so much just driving it around on the road, but the first time you're in the field with it, it's clearly a step above anything else that we've done there from an operator control of his steering. So
what else do you think is going to be significant change driven by AI in terms of controls or any other aspect of the machine?
That's a good question. I think that if you take a look at the consumer electronics area and take a look at where automotive is going with kind of adapting some of those consumer electronics and making some of those connections easier, regardless of what area you want to look at there, you can probably assume that we're investigating it to see if it's valuable enough for the farmer to do it. We've probably obviously got some added complexities if you think about the complexity of a combine harvester versus a car or even a tractor. It's a level of complexity and a level of safety requirements that's kind of it's in a different stratosphere. So we've got to keep those things in mind too, and be as responsible as we possibly can. But when you think about things like voice control, and connectivity to your electronics, connectivity to the outside world, the data that becomes available to you while you're harvesting, especially as we are trying to take, job by job of the operator away, right? That's probably one of the things it's probably the clearest evolution, but I would speak to it anyway, that says over time, we are taking the most stressful pieces away from that operator's, top of their mind. So it allows them to focus on other things, whether it's the grain market or the incoming weather, or, should I trade my machine or whatever else it might be? What's that truck driver doing? All those kinds of things that are going on within harvest, we want them to be able to focus on those more. And when they can, they're going to want to also have the information of those other operations, of the other things that impact their farm.